name is Christopher Farrington. I'm the Chief Operations Scientist at the CHARA array. I spend all my time working on making sure the data continues to flow from the CHARA array to the investigators who propose the projects. I do the scientific scheduling for all the proposals that are submitted to us. I supervise the observers whose job it is to take the data and interact with the individual investigators. I also spend a lot of my time working on the mobile telescope design, which is the model of which is behind me. My personal research is on binary stars and the fundamental properties of individual stars. The only way to get direct measurements of masses is to work on double-line spectroscopic binary stars and get their physical orbits. It is an important component of measuring the properties of stars, because we need masses to benchmark all the rest of the measurements that we take that are all done through theory. I work with, I have two operators under my command. They are non-scientists, but they've adapted very well to working with a very difficult instrument. Most of the operators for telescopes only have to work with a single telescope. Our operators work with 6, plus all the associated components that go along with making this array work. It is a significantly difficult job, and you would expect it to be at least a PhD level. And these operators are able to handle the significant workload with just their basic education. They started out as operators on the other telescopes at on the Mount Wilson as outreach operators. I also work with all the local CHARA group, which consists of a variety of people, mostly for engineering, for maintenance, for making sure this array works. Problems that arise during the night are dealt with by the day shift, so communication has to be done between all the people who work at night with the people who work during the day, and make sure that the problem is discussed cleanly and efficiently so that they know exactly how to reproduce the problem during the day. I'm also the point of contact between all the individual scientists that visit here who come to take data from the array. I'm the one that takes care of all the scheduling for them. I'm the one that takes care of their science operations programs. So I interact with just about everyone who works, who passes through the array at some point or another. The future of CHARA is, we're just getting started. We have 6 telescopes that have been here for 20 years, but we're expanding this year with the beginning of our mobile telescope, our 7th one, which is fiber-fed. Our location site has a lot of limitations for allowing direct light pipe access, which is how we get the light from the telescope to the combining lab. But our future is fiber optics. We're setting up the mobile telescope to transport the light from various sites on fiber optics into the lab, and then allowing it to be recombined, which also allows us a lot further distance and more flexibility on how we place our telescopes. The mobile telescope is the first step in a fiber-linked array. We plan on fiber linking all the current telescopes in addition to the new one. And if this is successful, we plan on adding 3 more that will be at one of various 9 sites, so that we'll have multiple options on how we do this. We're also planning on upgrading our 1-meter telescopes to 2-meter telescopes to vastly increase the light collection power due to all the losses we get from piping the light from the telescope to the optical lab. The desire to move forward is not just a one-way street. We need certain things to advance. We come up with ideas, and we need mechanics, and we need engineering that does not exist. So we put it to companies to design something for us that will do what we need, and then they will build it, and they can use that design in the future. So we both cross. They innovate on their own. We ask for innovation, different types of innovation. We both trade off the innovation in different ways. We work in the same wavelength regime as the JWST, the infrared, and we have a lot of complementary science programs. One of the interesting things we're looking at is not necessarily the images of JWST, but the other instruments that are going to be used soon. The spectrographs, the coronagraph, all the different types of infrared imaging that we're going to see will allow us to see will be complementary to our scientific work. They'll give us the images that will allow us to see different parts of stars, because the infrared often is heated gas or disks around stars, that if we will see disks that we didn't know existed, so we'll have new targets to look at. It's very complementary to us. It's really exciting, the fact that it finally got launched and we now get some really good images that we've been waiting so long for. It may involve people, the general public's understanding of the universe, through which we can explain new things that they didn't understand before. For scientists, it's going to provide new data, new avenues of research, and looking back further into the early universe will provide a lot of insight into the data we already have and the new data we're planning on collecting.